Welcome everyone to this meetup, another meetup. We're very glad today and very honored to have Emmanuel to talk about outlier detection with the Elastic Stack. Many thanks to Elastic for hosting this. Really appreciate it for the support. A little bit about our meetup group, the AI in testing and testing AI meetup group. My name is Chris. Oops, forgot my camera. My name is Chris, or Himing, and I call myself the chief instigator of this whole meetup group. This meetup group was started about 2.5 years ago. Initially was in the Santa Clara, Silicon Valley area, but because of COVID, we've expanded it to be online, and we've had a lot of success getting people from Europe and Asia to participate as well. Besides myself, we also have Jason Arbon, who is the co-author of How Google Test Software, and CTO of Test.ai. Who's an advisor, and also Ron Brashear, who is a VP at HPE, who's also a very avid supporter and advisor for the group. So we're always looking for speakers, and when this whole COVID thing is over, we're also looking for venues and sponsors for food. If any of you would like to volunteer or know somebody who would be a great speaker or has a great topic to speak about, please let me know. You can reach out to me at the meetup group. And for those who just joined the meetup group, there's also a member survey that helps us understand what you guys really want to, what sort of talks you're interested in. Huge shout out to our partners. Well, partner AICamp has been a great partner for us. They have supported us in terms of publicity, as well as using their Zoom webinar facilities for a number of our meetups. And last but not least, I'd like to extend a huge shout out to my employer, Climate.Corp, for allowing me to take some time to do this, which is something that I enjoy a whole lot. For those of you who do not know, Climate is a leader in the digital agriculture space. If you're interested to find out more, please head to climate.com. We have a whole bunch of videos that talk about what farming is about and how we accelerate and we support the farmers in the number of the tasks that they do. And that is all I have. I will hand off to Emmanuel now. Let me stop sharing.
Perfect. Thank you, Chris. Awesome. So let's get started. Let me just share my own screen. Okay, you should be able to see my slides now. Okay, fantastic. Thanks everybody for coming and for spending a bit of your morning. In this case, for me, it's late this afternoon. I'm in London. Thank you for spending some time with us. Today, I'll take you through a practical demo of outlier detection with machine learning for Elastic. We'll talk a little bit about Elastic and introduce the stack of tools. Many of them are completely free, actually, so there's could be other interesting things here for you besides the machine learning module. So, yeah, and then we'll dive into a practical demo, take some data from a file, from a CSV into a Jupyter notebook, and from notebook into Elasticsearch, and then we'll play around with it there and do some basic outlier detection. So first off, a little bit about Elastic, if you haven't heard of us, or about the Elastic Stack. It's quite a popular stack in observability and like web monitoring and things like that, but it also nowadays expands to maps, security, map solutions, security, including anti-malware for servers, and enterprise search, things like throwing all of the docs from your company into one place, and so you can find them more easily. But really, the whole kind of company and the whole story begins with Elasticsearch, which is an open source analytics and search engine. Essentially, you can throw numbers at it, you can throw text at it, sentences or words, and it will return queries very, very quickly. Then around it, there are several other pieces of software. So today we will be using Kibana quite a lot. That's kind of like a window into Elasticsearch, basically a graphical user interface for the data store to allow you to make use of the data in there much more easily. Then Beats and Logstash, we're not going to talk about. Those are to do with web monitoring, kind of siphoning off metrics, logs, and other kinds of data, and pushing it into Elasticsearch. So where does machine learning fit into this? So machine learning is, with a few small exceptions, a commercial module. Elasticsearch is an open core company. So a lot of these, like everything actually that you see on the screen is completely free to use, and the code for it is published. It's actually, the machine learning code is published as well. You just need a license to use it. So what we'll be focusing on today is actually Elastic Cloud down here on the left. So the way that you can use machine learning, as it's a C++ module that integrates with the Java-based Elasticsearch data store, you can download it yourself and run it yourself on your own infrastructure, both Elasticsearch and the machine learning module, and that but that will require a subscription, what we call a platinum subscription. So like it could be expensive, but of course it'd be worth it depending on what you want to do. But if you just want to play with it, what I'll be showing you today is how to use it on Elastic Cloud, where you don't have to like actually fork over thousands of dollars or more, like just to play with something. And there's even a trial period. So basically for 14 days, you can start free instances and play with them. And that includes machine learning. So that's what we'll be doing today. All right. So what's the idea? Like, why did a data store company decide to, before even getting into security and enterprise search, why did we decide to do machine learning at all? So we saw a bit of a need for it because the current workflow requires a number of tools. So people usually, not everybody, but a lot of people will use Jupyter notebooks, and where they use things like pandas to visualize and explore, pandas, matplotlib, NumPy to store and analyze the data. And then they might use scikit-learn, as by now like PyTorch, a whole number of libraries that will allow you to train and evaluate a model. And then for distributed compute, you might integrate those models into Apache Spark, like possibly rewriting parts of them so that they work better in production. But that's the general workflow. And the idea here, the idea that we had is, okay, you are going to need to use Jupyter notebooks and so on to interface with other systems. So we can't, we're not going to try to touch that. But why don't we try to provide the visualization and model stuff directly in your production data store, which I think is quite an ambitious undertaking, personally. It's been really hard to upgrade the features so that it can do a lot more. So today we'll dig simply into outlier detection, but as we'll talk about in a second, it's capable of a lot of other stuff as well. So there's both supervised and unsupervised learning by this point. So The stack includes transforming your data, filtering it, and visualizations, as well as actual analysis, like in this case, outlier analysis, but you'll see all that in a second. So that's how we started off. We started with anomaly detection and outlier detection. So this is the unsupervised bit of kit. So you can give it a number of data points. It sort of varies depending on the variability of the data. It will vary how many data points it will need to be able to give you a more accurate reading of what is an anomaly. But once it is able to do that, it's quite useful. And then there is also supervised learning supported as of more recently, and that's been used like by banks for fraud detection, for example. And we have a language identification module as well. Okay, now let's get on with it though. So we'll be, as I mentioned, we'll be going through some Jupyter notebooks and then doing some outlier detection. Okie doke. So let's first start with like, okay, what would you need to do in order to use this stuff? So we'll start just at the homepage of Elastic Cloud. So you register for a free account and that you get the 14-day trial there. And that's where you will end up. That's the home screen. So from here, you'll click Create Deployment. And you'll move on to, yes, you want Elastic Stack. Here you can see the other solutions, enterprise search, like the observability, like web monitoring specialization, and security specialization in the stack. But it's all using Elasticsearch at the core, and machine learning integrates with a number of these, like for more real-world applications. All right, but we're not doing just a product demo today. We're going to do some actual data ingestion. Right, so I would suggest here just staying with IO optimized. Then you just pick supplier you like. I like Google Cloud the most. For you folks, San Francisco, I guess the US West would be the appropriate region in most providers. And then you would hit customize. So here, zoom out a bit. Here, if you're just playing, set this to simply one zone. And you probably don't need more than a couple of gigs. This is for Elasticsearch itself. You will need to click here to enable the machine learning module. And over here, as you can see, this is free. So that's excellent. Yeah. So the Elasticsearch one, you always have to pay for. But the machine learning module is in the trial. Yeah. Okay. Then Kibana, that's the graphical user UI. And then we don't need application performance monitoring because we're not doing web monitoring. All right, and then we hit create deployment. So that's what you would need to do. But I'm not going to make you do that, of course. I'm not going to make you wait while that gets done. I have a deployment started already. And so we'll see how to use the data from there. Okay, so this is the notebook, and we'll quickly run through it. So we have some imports. We want to display all plots in line right in there. We'll just do a bit more settings, visual settings around the plot. I say where our data is. And all right, I can ignore that warning. Now the data has been loaded successfully. And you'll see in a second what it looks like once you load it into Elasticsearch, because the whole point is, okay, how do I explore this with Elasticsearch? So just set some headings there. And then we do a little bit of cleanup just to make sure that everything is a float. Yeah, and just to remove invalid numbers. And now here we can see these are a number of apartments that we have in our data set, 13,000. And you have this many houses. It's mostly houses and apartments, as you would expect. So you can do some basic analysis and visualization in here. In fact, well, you could do very advanced analysis and visualization. I'm only doing basic ones because I'll be doing the rest. Elasticsearch. Okay, so now here we come so far, okay, just Python ingest some data, Jupyter Notebook, fine. Here we come to the first Elasticsearch specific thing, and that's the schema. You can go without a schema in Elasticsearch as well. It will just guess from the documents, the first document that you ingest, it will guess the field types from that. So if you have just unknown data, you can also use it for that. But the thing is, then afterwards, it will stick with those. So that's the reason why I use an explicit mapping, as we call it, or as you might know it, a schema, because here, for example, the location will actually contain inside it a latitude and longitude field. And if you don't say that, okay, this will be of type geopoint, and then inside you will have location geo, then inside you will have two subfields that are floats, like I have here. So you probably want to avoid that because if you want to use the mapping functionality, then that's useful. And you also will probably want to save space. Basically, wherever you have a URL or an ID in Elasticsearch, instead of using a text type, you use what we call a keyword type. So that means don't break it up. Don't use it for full text analysis, because the parts of a URL don't mean anything. I'm not going to search for just a part of it. Of course, if you are going to search for just a part of it, then leave it as text or define it in both a keyword field and the text field. Anyway, that's enough about data types, some basic stuff. I want to run that cell and just check. Yeah, run all the necessary cells. Okay, and so here we have a very simple generator. What we want to do here specifically is for the location field, we want to put a lat and a lon. And so for each listing, AirBnB listing, we want to set the latitude and longitude. All right. Okay, so then we will want to use the Elasticsearch Python client to create our index. So where did I get this information from? So when you create a deployment, you will get over here an Elasticsearch endpoint, and all you have to do is hit copy, and then I will give you this thing here, as well as the port string. So you're away. The username and password. When you hit create deployment, you will receive a user and password. You will only see them once. So at this point, you need to copy them or download them, as it says. And then off it goes. So that's how I've gotten this data here. It's pretty straightforward, I think. Right, so let's run these cells. Okay, so the index is created, and now in the Elasticsearch Python client, there's a helper that will bulk upload data, which is the fastest way to upload anything. To be honest, we don't have that much data here. It's not millions and millions of records. So that's it, and then you just run this one. Now, I'm not gonna make you wait for the run and so on. I've already indexed it, of course, not to waste your time. So this is what the data looks like. And okay, right. So something just in terms of basic navigation around the thing. What might we be interested in to see? Because this is kind of quite hard to read. I personally would find it difficult to, if I did a search in here, I would find it difficult to navigate myself. So perhaps we will want the name, maybe the price. What else? I guess number, the people it accommodates, and number of bedrooms could be interesting. cleaning fee together with the price. But so by clicking on that third button, toggling the column, as you can see, we get this sort of tabular view. And that's your most basic way of navigating around. The way I got to there is from your cloud deployment, you hit launch on Kibana, and this will open the Discover endpoint. And from there, you can select which index pattern, like which index you want. And so like if we were going with what's indexed, if we're going with actually indexing this rather than my pre-prepared example, then you would be looking for Airbnb listings in there. Okay, so that's it for this. Let's actually go to machine learning now that you have some idea about the stack. So the way we go there is from over here. It's this little icon with the 6 dots, machine learning. Okay, and that is us on cloud. So we'll be, for outlier detection, we want an analytics job. So let's go and do that. Okay, we want to create a job. It will be outlier detection, and we could give it, what ID should we give it? Let's go with demo outliers. As for the source index, we are going to use this one. We're just going to look at New York City today. And for the destination index, we are going to say, just like the job ID, demo outliers. Okay, and we also want to create an index pattern. So we will talk about what an index pattern is in a bit. Now, from here, I'll say enable the advanced editor because I want not to exclude fields, but I want to only focus on specific fields. So the way that unsupervised learning works in our machine learning module is you, like it looks at the, like basically which records are unusual. Because Elasticsearch has very fast aggregation, so it can look through like what are the unique values in a data set very quickly. So this will look at what are the unique values, and it will go, okay, this one is significantly different. It's a numeric value. So I will give it a higher score, but it's sort of up to you to interpret like whether that's correlation or causation between the two things. So it'll just give you an outlier, like this is different. And we call those influencer variables. Okay, so we want to work on the price. By the way, if there are any questions, just type them in chat and I'll look afterwards and answer them if I can, or I'll direct you to where you get your answer if I can't. Okay, so we just want to analyze price and bedrooms for potential, the number of bedrooms and the price for potential outliers. Okay. All right, so this is started as job, and we can track its progress over here. Okay, so at the moment, right now, what's happening is we are re-indexing the data from the original listings into a separate index first so that we don't mess with the source data in any way. Then in the results, we can refresh over here. Okay, well, it's got a little bit more to do. There's also an automatic refresh if you're so inclined. Okay, yeah. Almost there. There is also a log of what is happening. So this is your cloud node. And this is your job definition here. All right, okay. So we have the data fully analyzed. Right, so what does that actually look like? Okay, so here is where we need an index pattern for. And an index pattern just allows Kibana to do certain things like auto-completion. Let me show you what I mean by that. So let's go demo. Oh, it's a new index pattern, so I'll need a quick refresh. I'll just yeah, there it is. All right, so what's the use of an index pattern? So we already created an index, right? That's like a table in Elasticsearch that holds the data. And we talked about mappings, which are like the schema for a table. So we have an index that holds the data, and we have mappings, which are the schema. So why do we need an index pattern? So we can use it, we use that for here for autofilling. If you had dates in here, then you would be able to see a date histogram, like of when the records are distributed in time. It's only one date, because in this case, they're all indexed at the same time. But what you could do, for example, is autocomplete on region. There you go. So this will autocomplete both field names, as you can see here in region, and it will autocomplete all possible values as well. I wonder if this is going to work with name. Yeah, okay, so name is an analyzed field, so it's broken up. That's just showing you the top 10 results there. Right, so anyway, that's what the index pattern is for. So it's for the graphical UI to know how to handle the data. Okay, right. So we have created our outliers index, and the documents look something like this. I'll just pull that. Okay, let's look at the pre-prepared example in live demos. Right, yes, there we go. That's the, okay. But for some reason I can't find the exact thing that we run in there, but no matter. This is what the index looks like. So we have an accommodates. So what we have is a feature influence. So each of the influence variables. So in the case of our job, it would simply be bedrooms and price. But what we would want from there, like where we want to go from there, is actually if we look at similar jobs. So say that you were running this analysis together with a colleague, and like you had a longer running project. So how can we see what like other people have been doing? And as you can see, this is the interface for looking at all that. So if we have a look at a job that I created earlier, so here we see something interesting. We actually have a query, so we can leave out certain parts of the listings. We don't need the region in here because it's all in New York City anyway. But those could be interesting to add, and also add it, or your colleague, let's say, has added an accommodates field, which is the number of guests that it fits. So that's besides price and bedroom. Okay, so I'm not actually going to make wait for the job because I also need to be mindful of time, and I want to show you how to visualize this stuff. But let's see, we call this demo outliers clean, and the source index is still the listings here, and the destination index is call it again demo outliers clean. Okay, and we will want to create an index pattern if we were to run this. And so here, again, similarly, you would say, okay, I want to include only specific. You could just analyze all the fields, but that's waste of time, basically, if you don't need all of it. So here, we will want to add, and this is what's really useful about this interface. You can just copy this stuff from somewhere else, from another job. Let's say that your colleague was running. Okay, right, so there we go. And as for the query, so in the graphical user interface, you can only pick an index from like which to get this information. So you kind of imagine if it was SQL, you would get the entire table. And actually to do filtering during a machine learning job, you would need to zoom out a little. You need to go here into the advanced settings. And besides the name of the index, you also say, okay, this is the query that I want to apply before I run any outlier detection analysis. So the reason we're putting those in there is the availability is for, we just don't want listings that are stale, that people are not updating anymore. So the availability calendar should have something in it. And we want like basically not bot and spam listings. So we want some actual reviews in there. So we're leaning on Airbnb's moderation stuff for that. And we want more than 0 guests to be able to be accommodated. And usually the cleaning is for hotels and other stuff like that. And we only want kind of more traditional listings here. And more than 0 bedrooms. So we want to filter out weird stuff. So if you wanted to do that, you can do that during the job creation itself. Okay. So I'm not going to run this because, yeah, it's just in the interest of time. Now, there is a useful feature here called a data visualizer over here. And show you what that to do. So if we selected the outliers, yeah, so it's warning us that there's no time in the, there's no date time. There's a timestamp for the records, which is fine for us. We're going to be looking at other stuff. Yes, so this will give you distributions. This will give you top values. It's just, I think, quite useful. So for example, let's see, maybe like number of reviews. Okay, so because we have filtered out documents without reviews, we start at between 3 and 6. That's the distribution there. And then it tapers off. And we have very few properties that have like 100 and only 5% of properties have like over 100, between 120 and 170 or so numbers of reviews. Anyway, this is very, very useful. This is totally free. You can download like the Elasticsearch machine learning and use this thing if you need it. So I can turn off the live refresh if it's annoying you. Okay, so What do we do with those? So I've shown you kind of like quite basic stuff. Okay, this is how we get the data in, this is what the records look like, and this is how we create jobs to analyze it. But let's like actually make use of this data and visualize it in some way. So in order to do that, you would go over to here. So far you've seen Discover, where we looked at all the records, and you've seen the machine learning like job management interface. And now we're going on to visualizations. You can create individual visualizations in the Visualize tab here. Okay. And so you can create different types of visualizations. So with Lens, you can play around with the data a lot. It's kind of a drag and drop and suggests possible visualizations for you. It's quite a cool feature. And you have areas, horizontal, vertical bar charts, heat maps, actual maps, which we will see in a second. So there's a lot of possibilities. Lines for trends. But anyway, what is more interesting is then that you can put all of those together in dashboards, which is this button over here. So I'll first show you what we're going to kind of aim for. So that's the map. Right, okay. So I'll show you first what we're going to aim for, and that's going to be one of the dashboards over here. And then we're going to basically recreate it. Okay, so we have a tabular view at the top, but this one is sorted by how weird the record is, like how much of an outlier is it actually. Then we have a price distribution here to demonstrate a bar chart. And then the most interesting part where we're going to go hunting for interesting records is the map over here. Right, so how do we create something like this? So we would start by just hitting dashboard new, of course, and from then on we can add more information. Okay, right. Now we want to add some stuff to this. Start with the simplest thing, which would be the bar chart. So I can create a new visualization, vertical bar chart of the price. So if we go with the prepared outlier index, yeah, okay, that's not very useful. Okay, but of course we want to have an x-axis here, and here we want what we call an aggregation. So those are just like in SQL. If you do a group by, then this is what that does. So in this case, we will be doing a group by with an interval. So we want like, okay, $10, $0, $10, $20, and like how many records are in those ranges. And this will actually be automatic. So we don't have to say go from 0 to 1000 and give me the ranges within that. It will just look at all the unique prices in the index. Oh yes, of course. I want to specify a field. Okay, histogram of price. That's a large bound. So this could be because we're looking at two. Let's just make sure to select all the data. I think it's all indexed on one time anyway. But, yes, it's all correct. We get to truncate. Okay, well, anyway, let's set you don't need to give it a bound, but for some reason it's decided at the moment that it's a bit 20,000 minimum interval, and I specified less. Okay, let's have a look then at what the price visualization in the regular dashboard, like how that is set up. You know, if you run into a problem, it will happen to you too. Let's have a look. Okay, so this one is with interface of 40. That makes sense. If we go to all visualizations, it should be one by price. So if we edit that, so we've got a histogram here of the price field, minimum interval of 10. And in this case, there are bounds, so I don't think that should make a difference actually here. Yes, it does not. Okay. Oh, so if we do the same thing, histogram, price, tickets. Okay. I have to say it's, I'll have to check what's wrong with it, but this is how you would set it up. You get the histogram of the price field and you give it a minimum interval. From then on, you are away. That's that would look like. So let's add it to our custom dashboard. And create a dashboard. Let's say add, since it already exists. Okay, right, there you go. That works. So we've added that. Okay, how do we add, actually, in the interest of time, let's just go with the map. How do we add the map to this? Because this is actually the most interesting part of the whole thing. Okay, well, we would say add, and then we would create new visualization. And we want to create a map. Well, that's loading. I didn't say that dashboard, so I'll just make us a new one, and we'll call it demo. Okay. Edit. All right, okay, so we get that. Now, right, here we start with a map of the world. This is using open map tiles and OpenStreetMaps. Okay, so what we want, we'll create two layers. We'll create one of just listings. And we're not, because this is the raw data without like which records are outliers, we are not going to be very bothered about how it looks. Let's say I wanted to look like that and make the icons slightly bigger. And states there is New York. Then I selected the wrong index in a hurry. We should be looking only at New York. There, yeah, there we are. So that displays perfectly fine. Okay, so we'll call that listings, and that's like our row listings, as I said. And really the only important thing here is we don't want to display an airfield icon, and we want to make them a little bit bigger. Okay. All right, so this is what that looks like. Okay, it's pretty unreadable, which is fine. Like these are the role listings, and we're looking at outliers specifically. Okay, so let's look at those outliers. Yes, great. Okay, that's working. And we're gonna call this layer outliers. Now in the tooltip fields, we probably want the name of the listing. We want the URL, likely, just so that we can click onwards. We want both the variables, like the number of people it accommodates, the number of bedrooms, and we also want like how much is that variable influencing the record. So how much is it contributing to us thinking that it's anomalous. Okay, so we want to add all of those. We will want to sort by the general outlier score. All right, okay, so now instead of those circles, we will also make these appear as buildings, but instead of a solid fill color, we are going to say, well, I want to see values. And for that, we're going to go with outlier score. Okay, and this gives us a kind of a color style. You can also define your own, like between 0.1 and 0.5. It's one color specifically, and then it's a different color. Okay, I think just gonna make these a little bit bigger. All right, okay, so if we turn off the listings layer, and if we say fit the data, that should okay, right, because it's the general outliers index. It'll zoom us out to the entire data set, but what we'll do here. All right, okay. So that's still a whole lot of outliers. All right, so what can we do to filter this down a little bit to basically look for interesting places in this data set? We can first say that the outlier score should be high. So that's gonna filter out all of those yellow ones where they are weird, but they're not weird enough. All right, so from here, what else could we do here? So here we would be able to see some outliers. Let's for example, have a look at this one, Empire City. I believe I've already got the link open, so I don't have to wait for it. Yes. Okay, so it is an outlier, and so what does our record say about it? So our record says that the price is the biggest influence on why it's an outlier. And indeed, the price is $1,000, but it says 1 bedroom, 2 guests. So, and if we check to see whether that's true, it is indeed for the next available dates, which is all the way in 2021. It is actually $1,000 per night for this hostel. So, okay, it is an outlier and it's interesting, but we could have just sorted by price. So that's maybe not so insightful. Okay, so what can we do that is more interesting here? we could say, okay, this was just a very high price. So what about if give me lower prices? Okay, so we get some more records. Now, let's also make use of the accommodates field, because like this is, I guess, what's super expensive is not that interesting. What's like cheap and accommodates lots of people where we can like go with our friends is possibly a lot more interesting to us. And there are a couple of records here. I think this one here, so if we click it, it's already going through them, of course. It says that the number of bedrooms is the largest influencing variable. So it's an unusually high number of bedrooms. And if we open it, indeed, it says 16 guests, 9 bedrooms. And for the next available dates, it is indeed around $300 per night. So $300 for 16 people, or up to 16 people, at least 9 people. That's fantastic for New York. So, okay, because we're responsible with coronavirus, we're looking ahead, not going around New York at the moment. Don't do that. Okay, so as you saw in the beginning, like when we were defining the map, there is by this point quite a big difference between what we see now in terms of outliers that are fitting specific criteria, and between like raw data. Yes. Anyhow, as you saw in the very beginning, we had like the entire area was covered in blue houses. All right, that's the reason that it's not displaying anything is because it's we've got filters. So we've got the global filter, and there we go. Because this information is not available for role listing, so no role listing has an outlier score, right? So of course there is no data found. So a lot of this you could do just basically by sorting and just looking at, okay, if I sort by price and I sort by bedrooms, you could get some of this, but it would be quite difficult to get like cheap places that are also able to support a larger number of people, because they'd be drowned by places with a similar price. Because there's a lot of cheap places, but not a lot that can do a lot of people. So as a basic example, this is how outlier detection works. Yeah, we've found ourselves a good deal. Now, since it's taken a little bit longer, let's go back. Slides. Okay. So, so far you've seen how to get your data from Jupyter Notebook into Elasticsearch, how to do outlier detection, and we explored the data a little bit. If you want to learn more, there's the Elastic Machine Learning documentation. There's a language, like if you're interested in other functionality, like I didn't show this today, but this language classification This is also free, by the way, just like the data visualizer with the distributions that I showed at one point. So you don't need to pay anything. You can download it and use it yourself. If you have any like NLP needs or need to identify like English or other languages, I highly recommend checking out that blog post. And then there's further anomaly detection based on time series data. It's quite a short video that is quite good and shows it very clearly by our head of machine learning. I recommend checking that out. If you have any questions,